Hey, this is Randy. If you remember how to add and subtract polynomials, much of this video will probably feel like review. The difference is that today, instead of using variables like x or y or n, we'll be using the imaginary unit. Let's do this. So before we fully simplify this expression right here, let's remember a couple things. First thing is that this I right here is specifically defined as the principal square root of -1, just like we know that I squared is equal to -1, right? Another thing to think about is the fact that when we have a plus right here in between this expression and this expression, and we also have no number in front of this parenthesis or this parenthesis, we can actually ignore the parentheses. That will not always be the case. For example, if we have a minus right here, then we need to distribute that negative, and we'll do an example like that here in a minute. So first of all, let's rewrite all this with no parentheses. So we have 4 minus 3i, and then we have plus 9 plus 7i. All right, now the real numbers can be combined and the imaginary numbers can be combined. So we're going to go with 4 plus 9 to get 13. So we have right here 13. And then we have -3i plus 7i, or you could think of it like 7i minus 3i. That'll give us a positive 4i. So 13 plus 4i. You'll notice here that the imaginary portion is written second, and the real portion is written first. And that is the standard way to write a complex number. So with that answer, 13 plus 4i, we are finished with that problem because we cannot simplify it anymore. So 13 plus 4i is the simplified version of that original expression. All right, let's look at another example here. This time we have a subtraction problem. So before we do any combining, let's get rid of the parentheses. And in order to do that, we need to imagine that this negative right here is a -1 that we distribute to the 6 and to the -7i. And then we'll be able to write the entire expression with no parentheses. So this first part we have is 5 minus 2i, right? And then next we have a -1 times 6 will give us a -6. So minus 6. And then -1 times -7i is a positive, negative times negative, and that will be a positive 7i. So plus 7i. Now we can combine the real and then combine the imaginary. So 5 minus 6 will give us a -1, so a -1. And then we have -2i plus 7i, or 7i minus 2i. That'll give us a positive 5i. So we have -1 plus 5i. And that cannot be simplified anymore. So that is our final expression of that original expression fully simplified. All right, let's do one more example here. This time it probably looks a little bit more strange because we don't have any visible imaginary numbers in the first expression, but our process is still very similar. You know, you could think of this right here as 4 plus 0i, or you could just think of it as 4. Both ways work. So let's distribute this -1 right here. So we have a -1 times -5 and a -1 times -4i. So first of all, we have just 4, which came from right here. And then we have -1 times -5 will give us a positive 5. So 4 plus 5. And then we still have, let's see here, a -1 times -4i. That'll be a positive. So we're going to say plus. That'll be 4i. Plus 4i. Right? Now, you know, 4 plus 0i, or 4, mean the same thing. And so that means that there are no i's, no imaginary numbers to combine with this. So the 4i cannot be combined with anything, but the 4 and the 5 are both real, so we'll combine those. So 4 plus 5 is 9, obviously. 9, and then we still have 9 plus 4i. 4i. And this expression right here cannot be simplified anymore. And with that, we are finished with this lesson. And we'll see you next time.